Okay, so let's start now. Hello, 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 hello. Yeah, I'm audible to you. Okay. So let's start the session. So before we start the session, I want to introduce ourselves. My name is Krish Naidu. I am a founder of a supply chain analytics company, and the name of the company is Mathanal, and our website is www.mathanal.tech. This is a website, and we are into this business since last 6.5 years, and we have been providing consulting as well as training services globally to industrial clients, retail clients all across the world. Right. And personally, I have an experience in this field of 23 years. I have an experience in this field of 23 years. So my experience is into supply chain, software, product development, also into supply chain analytics, means making decisions using data and mathematical algorithms. I have been also into supply chain operations like production planning, inventory management, procurement, logistics, transportation, warehousing. I have provided services to I have done supply chain consulting to almost 100 plus clients till now. So the experience which I have is a very rich experience. So what I did is I converted this rich experience of 100 plus clients into a consulting package and a training package. And I'm giving these trainings and this consulting based on my aggregation of what I have built with clients in the last 23 years with 100 plus clients, right? That is what I have summarized those on entire training, entire consulting into packages, and this is what I am delivering. So the training and the consulting which I deliver, they are not academic, they are the industrial content. It's not an academic content. Okay, so people, after learning this content, after learning these programs, they can directly go into the industry and apply those learnings, templates, mathematical algorithms right from the day one into their company. So this is going to give in a very helpful, which is this training content will be very helpful to themselves as well as where they work, because they can bring a new perspective of data driven decision making into their industry. Okay, this is what about ourselves. And today, what we are doing is that we're going to work on a model called adaptive single exponential smoothing technique. We're going to work on a technique called adaptive single exponential smoothing technique. So, what is this adapt? What is we will try to understand what is single exponential smoothing, and we'll move into the adaptive single exponential smoothing. So, suppose you have a road. For example, if you have a road, right, the road have bumps. right? The road have bumps, and a rider, like I'm a civil engineer. For example, I'm a civil engineer. I want to make these roads even for my rider with minimal investment. So what I have to do? I have to do the leveling. I have to smoothen the road, right? I have to smoothen the road so that my riders doesn't give any complaints, and that they move from one point to another without hiccups, without harming themselves, without harming their vehicle. So we have to smoothen this. So if I have to smoothen this, I have limited resources. I don't have too many resources to smoothen. So I have to smoothen this. So suppose if I can smooth the road like this, right? I can smooth the road like this. So this is the concept which is used in this is the concept which has been used in the forecasting. And that forecasting method is called single exponential smoothing. So we have to level the road. And leveling the road, we have to decide. So how much to level, what to level, that's what we have to decide. So suppose we have a formula, suppose we have a data called sales. This is my historical sales. So my first period in the month of January, I had a sale of 20. In the month of February, I had a sale of 18. In the month of March, I had a sale of 5. In the month of April, I have a sale of 15. In the month of May, I have a sale of 25. In the month of June, I have a sale of 4. Right? Now, I have to smoothen this particular data using a forecasting method called single exponential smoothing. So what I'm going to do is that I'm going to take a forecast, initial forecast. Let's say my initial forecast is 18. For example, this method also we'll discuss in the data. Initial forecast is 18. How to calculate this initial forecast? That also we have a method beyond it. So initial forecast is 18. Now I have to do the forecasting. Forecasting, how to do forecasting? I will choose a smoothing constant. That's called alpha. Okay. And this alpha is multiplied with the sales. I'll take 1 minus alpha and I'll multiply this with the previous forecast. This becomes my forecast. So FT is my forecast, alpha into YT plus 1 minus alpha into FT minus 1. So what is FT here? FT is the, say, suppose my FT is equal to March. T is time. Okay. T is time. I am forecasting for March. So what I will do? I take alpha into sales of March plus 1 minus alpha into forecast of February into forecast of February. This is my formula. So I'm smoothing this alpha. I'm smoothing the forecast. What is my smoothing constant? Alpha. So I'm smoothing the road. I'm smoothing the bumps. There's a bumps. There are various kind of there are various variations are there. So I'm smoothing the variations. The smoothing constant is alpha. So what is there? What I'm doing? Let's say the smoothing constant is, for example, zero point 0.4. So what is my, as per the formula? Zero point 0.4 into 18 plus 1 minus zero point 0.4 into this 8. Let's say this is 17, for example. So this is 18. If I do the forecasting for the period of March, right? So zero point 0.4 into 5 plus zero point 0.6 into, this is the forecast. Forecast of Feb. If I do the forecast of April, zero point 0.4 into 15 plus zero point 0.6 into forecast of March. So this is how we are going to forecast. So let's apply this technique into our data. Suppose I have a data here. Okay. So my first period is, so there are two timelines I have to build. One timeline is called time horizon. Time horizon will start with period number zero, and timeline will start from period number one. Time horizon will start from period number zero, and timeline will start from period number one. So my forecast for time, I will take the forecast for time horizon zero, and that will be the, let's say I'm taking average. My time, the first, the first forecast, the first forecast is my average, and that is for the time horizon zero. So I take this sales average, right? So total sales average is 115.94. That is my forecast. Now, what is my alpha? Alpha is, let's say I'm taking zero point 0.4. Now, what is 1 minus alpha? That is 1 minus zero point 0.4. That is zero point 0.6. What is the sum of alpha and 1 minus alpha? Alpha plus 1 minus alpha. What is sum of this? Minus alpha plus alpha cancel. You're getting equal to 1. Right? The sum of alpha plus 1 minus alpha should be equal to 1. So if my alpha is equal to zero point 0.4 and my 1 minus alpha is equal to zero point 0.6, what is sum of this is equal to 1, right? So this is a condition we need to fulfill. Alpha and 1 minus alpha should be equal to 1. So whatever is my alpha, 1 minus alpha is, if suppose my alpha is 0.5, 1 minus alpha should be 0.5. If my alpha is 0.6, then 1 minus alpha should be zero point 0.4, right? Suppose if I put alpha here, this is 1 minus alpha, okay, and this is sum. So if my alpha is zero point 0.1 and my sum is equal to 1, then what will be 1 minus alpha? 1 minus alpha, that is zero point 0.9. If my alpha is, let me drag this formula, zero point 0.2, zero point 0.3, zero point 0.4, zero point 0.5, zero point 0.6. So this, let me drag this. This should be all equal to 1. So if my alpha is zero point 0.2, then what is my 1 minus alpha? 0.8. See, I'm dragging the formula. If my alpha is zero point 0.2, 1 minus alpha is zero point 0.8. What is sum of alpha and 1 minus alpha? 1. If my alpha is zero point 0.3, what is my 1 minus alpha? 0.7. What is sum of alpha and 1 minus alpha? 1. If my alpha is zero point 0.4, what is my 1 minus alpha? 0.6. What is sum of these two? 1. Right? So the sum of alpha and 1 minus alpha has to be equal to 1. Okay. So now the formula which we are going to take, the forecast. What is the forecast formula? If I have to forecast for January 2023, then my alpha into sales of January 2023 plus 1 minus alpha into forecast of December 2022. If I have to forecast for February 2023, so what is the formula? Alpha into sales of February 2023 plus 1 minus alpha into forecast of January 2023. So what, if you look at this formula, if my formula is f of t, then alpha is y of t, and 1 minus alpha is multiplied by f of t minus 1, means previous forecast. So f of current period, forecast of current period is equal to alpha into sales of current period plus 1 minus alpha into forecast of previous period. This is the formula we're going to use to calculate our forecast, and we'll make it more intelligent once we move forward. So let's say this is my alpha is currently zero point 0.4. Okay, I'm going to freeze this into current sales, same trade sales, plus 1 minus alpha, which is zero point 0.6. I'll freeze this into the previous period forecast. So this is my forecast for the period number 1. So I'll drag this formula, right? So this gives me the forecast for the n number of periods. Forecast for if you look at, I'll double click here. Look at the red values. Look at the blue values. J1 is coming from alpha into red values. Red value is 135. That is for the same period. And L1 is coming from here, zero point 0.6. And D3 is the green one, coming from the previous period. So what is the formula for forecast? Alpha into YT plus 1 minus alpha into FT minus 1. Or if you read like this, forecast for the current period is equal to alpha into sales of the current period plus 1 minus alpha into forecast of previous period. For example, if I have to do a forecast for February, I'll take alpha into sales of February, but 1 minus alpha forecast of January. Okay? So like this, yes, that we will see. I will tell you how to find the alpha. That I will tell you. Right? As of now, we are putting it randomly. As of now, we are putting it randomly. But how to choose the best alpha, that also I will show you. So now we'll find the error. What is the formula for error? Error is equal to error is equal to forecast minus sales. Okay. Let's find the error equal to forecast. What is error? So I'll find the error here. That is forecast. This is my forecast minus. This is my sales. So this is forecast minus sales is my error. Okay. Now I'll find the total error. Sum of total error. What is sum of total error? Minus 44 plus. Right. If you look at here, how can be the total error could be 44? Somewhere we saw one error for one line is 45. Somewhere we are seeing error for one line is 62. Somewhere we are seeing error for one line is 67. Somewhere we are seeing the error for one line is 23. Somewhere we are seeing error for one line is 56. If I add all of them, it should not come 44. It should come more than 44. Right? So there is a problem here. So to eliminate this problem, we will calculate absolute error. So we'll take the absolute value, means absolute is going to convert a negative value into positive value, and positive value will remain positive value. So if you look at here, 31 is 31, but minus 23 has become 23, minus 17 has become 17, minus 40 has become 40. So when you are taking the absolute value, a negative value will become a positive value, but positive value will remain positive value. So now if I do the sum of this, I get 1615. This looks more reasonable. This looks more reasonable than the first one, right? Now I'll calculate the average absolute error. So this comes around 32. So per line, we have an average error of 32 units. Okay. Now what I'll do, I'll calculate error square. So if I do the calculate of error square, I'll take this value, error, I'll make it power 2. So this error is now showing us the square error value. Same thing I'll do sum of this. I'll take here in the case of average, I will not do not use the formula sum. I'll take a sum from here. I'll take the count. The count is 50. So I'll divide by 49. I'll reduce one value because this is called degree of freedom. So instead of dividing by count, we are going to divide by degree of freedom. So degree of freedom is count minus 1. Count of values, count of sample size minus 1. Right? Degree of freedom is sample size minus 1. So in this case of mean square error, we are not going to divide by count. We will divide by count minus 1. And then I'll find the root mean square error, square root of this value. This is called root mean square error. So if you look at with the mean absolute error, we got 32 units per line. But in the case of root mean square error, you're getting 38 units per the error of 38 units per line. So we are doing a forecasting, when you're doing a forecasting, you can expect that our sales and forecast, you can expect our sales and forecast are having an average gap of 38 units. The sales and forecast have an average gap 38 units. How much gap? Suppose if I'm doing forecasting, I have a sales, I'm doing forecasting. What is that average gap you can get? That is 38 units. Now, what we'll do, we'll calculate our mean absolute percentage error. So, for our absolute percentage error. So, what we'll do, now we'll calculate the absolute error. We'll divide it by the sales. And we're going to convert this into percentage. So this is our absolute percentage error. And what I'm going to do here, I'm going to calculate the average percentage error. And that we call as mean absolute percentage error. Look at here, the average percentage error is 47.41%. If you are doing a forecast with this model where alpha is zero point 0.4, so the per line means the gap between forecast and sales per line gap between forecast and sales is 47.41%. Per line, the unit wise, this is unit wise. Per line, the gap between forecast and sale is 38 units. Per line, percentage wise. Now we're talking about percentage wise. Percentage wise. So percentage wise per line, the gap between forecast and sale is 47.41%. So our alpha has to be decided based upon three factors. The alpha has to be decided based upon three factors. One is error percentage, second is bias, and third is called stationarity. So these are three metrics which decides the alpha. Okay, so let's calculate the bias now. So first, before calculating bias, I'll calculate my cumulative error. So first error is sum of Where is the error? Absolute error. Right? This is the error. I'll freeze this. So we're calculating the cumulative error now. So I'll take my error here. I'll freeze this error. Then now I'll drag this. So this is my E3. Freeze this. Okay. So E3, if you look at this is E3 to E4, some of this is, if you look at this is some of the three errors. Okay. Now if I click the second formula, this is some of the four errors, right? If I click the next one, this is some of the five errors. If I look at the first one, this is some of the first error, right? Some of one error. Now if you look at the second one, this is some of the two errors, some of the two period errors. This is some of three period errors, right? So we are finding cumulative error. And then what we will do, we'll find the bias or tracking signal. So what we will do, we'll divide this cumulative error by the absolute error. Okay? We'll divide this cumulative error by the absolute error. And then we'll get a bias signal here. So if any value is more than, if this value is less than, let's say, minus 3, if this value is less than minus 3 and more than plus 3, okay, then we'll say it is having a bias, or else no bias. So we look at where is bias. If you look at this data, I think we, okay, less than minus 3, okay, and more than plus 3. I think we're getting somewhere here. So this is 2.55 minus 3.55 minus 0.22. I think we don't have any bias here. We have a bias. This is 4.52. It's 25. So this is not reading properly. So let's see. So if this value is more than 3, if this value is more than 3, and if this value is less than minus 3, then it is 1, else 0. So it is not reading there properly. Let's say if I make this as 5, so let's check the bias now. Yeah, now it's working. So if you look at here, this is 25, it is showing bias. If it is 4, it is showing bias. If it is minus 3, it is minus 3.3, it is showing bias. Right? If it is showing minus 4.14, it is showing bias. If it is minus 14, it is showing bias. But wherever the value is between minus 3 to 3, if it is 1, it is not bias. So wherever is no bias, it is going to show error. Wherever is bias, it is going to show bias. So overall, if you look at this data, most of the data is not biased, and most of the data is very few points are biased. Now, what is bias? What is bias? Before we move further, we will check what is bias. Suppose your forecast is one direction. Most of the forecast is one direction. So your forecast and sales, right? Your forecast is completely in one direction. So if your errors, let's say this, these are my errors. If my errors are mostly in one direction, then this is biased error. What is the meaning of this? So forecast minus sales, right? So if my most of the forecasts are higher than sales, then it is called over forecast. So the error, if it is positive, if mostly it is positive, then I have a over forecast scenarios. Most of my errors are showing over forecast because my errors are mostly positive. Similarly, if my most of the errors are in the negative side, right? So what is the meaning of this? My forecast is smaller than sales. My forecast is smaller than sales. So most of the forecasts are smaller than sales. So this is negative bias. So what are we checking here is that is our model is adaptive. Is my model is adaptive to the variation in the data. If a model is not adaptive to the variation in data, then what will have? We will have this scenario of over forecast and under forecast. Mostly over forecast, mostly under forecast. If you have the scenario mostly over forecast, mostly under forecast, then we say that our model is having biasness. It is not adaptive. So if the model is which we are building, that's like the model which you have chosen over here, right? It is not adaptive, then we have to eliminate that model. We cannot take that model into forecasting, despite it gives you the least error. Okay. So, but if you look at in this scenario, we are getting most of the scenarios as no bias. So this model is very good. Till now, we have the error of 47.41% per line. That's called MAPE, right? Mean absolute percentage error. 47. This error is not good. 47% error is very bad. Because we got a very high error. 47% is a very high error. It's a very, it's not good. But as far as the bias is concerned, this is very good. Okay. So we have the bias under control. We don't have the error under control. Okay. So now what we will do, we'll bring the error also under control. So for that, the question which has been asked by Matthew, how to choose the alpha, right? So now I'm going to take an approach called optimization. I'll take an approach called optimization. Optimization. So what we have to optimize? We have to optimize the error percentage. What is the optimization? Minimization. We have to minimize the error percentage to get the optimal value of alpha. And this we are going to achieve by using solver. So let's go to solver. So in where you have to go to data on the right hand side, on the extreme right hand side, can you see solver here? This is the Excel tool which is available in the Excel solver. Now, after going to solver, I'm going to choose my objective. What is my objective? My objective is to minimize the error percentage, right? This is my objective. Minimize. So right now, if you look at here, it is given maximize, but we have to minimize. So I'm going to select minimize, right? I'm selecting minimize. After selecting minimize, I have to give the variable cells. What are the variable cells? Alpha and 1 minus alpha, right? I have to choose best value of alpha. So I have to give the variable. I have to give that as a variable because that is what we are going to modify. Because anything is variable will be modified. Then we have to add a constraint. What is a constraint? Constraint means the sum of this alpha and 1 minus alpha has to be equal to 1. So I'm choosing this one, click on 1, then click on this drop down, click on equal to, and then write 1. And then add the first constraint. Let me show you the constraint here. Look, see, P2. What is P2? P2 is our alpha and 1 minus alpha sum. This P2 is equal to 1, right? Now I have to add another constraint. The other constraint is that I want my alpha to be less than equal to 0.85. I want my alpha to be more than equal to 0.15. If you look at here, I have three constraints now. The first constraint is sum of alpha and 1 minus alpha equal to 1. My second constraint is my alpha to be less than equal to 0.85. My second constraint is my alpha to be more than equal to 0.15, right? And what is my objective? My objective is I have to minimize my mean absolute percentage error. So that's why I have selected minimize here. And my objective is mean absolute percentage error, right? I will click this make constraint variables non-negative and then I select the method. There are three methods here: GRG nonlinear, simplex LP, evolutionary. I'm going to select GRG nonlinear because this is non-linear data. After that, I'll go and click solve. And here we're getting an option answer that solver found a solution. I will accept this solution, click OK. Now look at here. It was earlier 47.1%. Now this error has come down to 12.53%. And what is the new alpha? Alpha was previously zero point 0.4. What is the new alpha? 0.85. Right? Alpha. Now we have got the best alpha. Best alpha is 0.85. So with this alpha, previously it was zero point 0.4. Now we got is 0.85. So with zero point 0.4, we had a error of 47.31%. Now with the alpha of 0.85, we have a error of 12.53%. Previously we had 38 units per line. The average error in unit wise per line was 38 units. Now per line the average error per unit is 11 units. So also has reduced. So from 47.1% error, we came to 12.53% error. And unit wise, we had a deviation. We had an error of 38 units. Now we came down to 11 units. And the bias is still under control, right? So this is a method called single exponential smoothing. But now we want to make this model more intelligent. We want to make this model more intelligent. So now we will make this model more intelligent. Hello, are you able to hear me, guys? Yeah. Now we have to make this model more intelligent. So what I will do, I'll set this data again. Now I'll make this data more intelligent now. I'll choose four values of alpha. I'll build a model with four alphas. That's three alphas. Alpha 1, alpha 2, alpha 3. Okay. And I give a value. I'll choose a random value of alphas. So number of rows we need 3. Number of columns we need 50. What is the minimum value is 50. What is the maximum value is 85. And we want integers. Okay. So let me go to rows. Number of rows is 3. Number of columns is 50. Number minimum value is 15. Maximum value is 85. And we want the values in integers. Again, it's the same way. So number of rows is 3. Number of columns is 50. Minimum value is 15. Maximum value is 85. And we want this an integer. So number of rows is 53, 15, 85, comma 1. Yeah, now we got it. So what I'm going to do, I'm going to divide it by 100. Okay. So now we have three alphas to consider: alpha 1, alpha 2, alpha 3. So what I'm going to do is I'm going to build three models. So I'll say SCS 1, SCS 2, and SCS 3. Okay. And my first data is 113, 113. First forecast is 113, which we already built in the previous model by taking the average. So now what I'm going to do, I'm going to apply first, I'll build a first model. First model, my alpha is, and the sales is, and 1 minus alpha in the previous forecast. So we have taken D3 into C3, D3 into C3. Now D has to move to here. So this is a forecast, and I'm automating this formula. So C into D, D43 over here, and this is E43, E43, and F43. Okay, S2. Okay, and this has to be C43. So let's freeze this C3. So we have to freeze this one. So C3, C4, C5, C6, C3, C4, C6. So it has to be, we have to freeze C here. So I'll freeze C here. Yes, C is freeze now. And I'll run the forecast now. Yes. See, by single formula, we are able to automate this. Writing a single formula over here, we are automating this. And now we're getting three different forecasts. The first forecast is for alpha 1, the second forecast is for alpha 2, and third forecast is for alpha 3. Okay. Now, what I'm going to do is I'm going to calculate the absolute percentage error. And we know how to calculate absolute percentage error. Just now, I have discussed in my previous model. Okay. So what I'm going to do absolute value of forecast minus error. This means SCS1 minus sales. Okay. So what I'm going to do here, this has to be freeze. My C value has to freeze. And I'm going to divide this absolute value of error by again C value of 3. And I'll drag this formula to right hand side. Right. So this is also automated now. And I'll take the percentage because we want to see this in a percentage format. Okay, I'll drag this. So I have three alphas. I have three forecasting models: SC1, SES1, SES2, SES3. And the full form of SES1 is single exponential smoothing with alpha 1. This is single exponential smoothing with alpha 2. This is single exponential smoothing with alpha 3. So we have built three models. And these three models are giving us three different errors. Now, what I will do is here from here, I'll choose a minimum error, right? So let's say if if minimum of if minimum of these three is equal to J3, then give me one. If minimum of these three errors is equal to K3, then give me two or else three. So JKL, right? JKL. So here we have to mention JKL. J3 to L3. If you look at here, minimum of these three is 26.03%. 26.33%, 46.70%, 37.52%. We have three errors. The minimum of the three errors is 26.03%. That's why we got the first one, 1. Look at here, the second one. The minimum of this three is 6.91, 6.90%. We have 6.90%, 15.55%, 7.14%. What is the minimum? Which value is the minimum? 6.90. And this 6.90 is coming from the first one. If you look at this one, row number 6. Here we're getting a minimum error from the second error, second alpha, 12.61%. That's why it's giving us 12, 2. Now what we will do, we select the forecast based upon this one. So I'll go to index, I'll choose the forecast. This is my forecast. In this forecast, whichever is the minimum, give me that forecast value. Look at here. The minimum error is coming from second one. 19.9. What is the forecast? 76.74. Because the minimum error is coming from the second alpha. So the forecast also has to be chosen from the second alpha. Look at this second one. The minimum error is coming from the first alpha, that is 8.62%. The forecast also has to come from the first model, first alpha model. So if I drag this, look at here. So right now this is minimum error is second one, 11.48. The model is also coming from second one, 71.35. In the second one, the minimum error is coming from second alpha, that is 9.90%. So the model selection, the forecast selection is also happening from the second alpha, that is 121.633. Fine. Sorry. In the third one, the minimum error is coming from the first alpha, that is 5.97%. The model is also getting selected from the first alpha, that is SC1, that is 131. Right? So this is how we are selecting our forecast. Now we have to select our error. Same thing we'll do here. Now index the error percent is what? These are the three error percentage, and we are going to select the error percent based upon this particular number. So if you look at here, the minimum error is coming from 15.31%. So we are selecting 15.31%. The minimum error is coming from where? 8.38% for the second line. So we're getting 8.38% on the second one. The minimum error is coming from second one, 3.81%. That's why we're selecting 3.81%. So this is an intelligent model. This is adaptive model. This model is adapting based upon the alpha, based upon the minimum error, and selecting the best alpha. Right? So what is total error now? Total average error. The average error is 50.35, 55.35%. It's a very high error. Right? So if I want to reduce this error, I can just press on F9. If I press F9, this is doing the iterations. If you if you keep on pressing F9, this will do the iterations. Right? So we saw 57, 40, 57 or 40, now it came down to 38%. Now we gone 26%. So this is doing iterations. If you press F9, because our alpha values are random values, right? These are random values. These are random values. Because it's a random value, that's why if you press F9, those random values will change. These random values will change. And once these random values change, you get your best error. Right now we have got 26.90. If you can do, if you want to do more optimization or more iterations, click on F9. Can you get better than 26%? Just check. Let's see. 32, 42, 44, 38, 32, 26. We got 26.09. Right? Let's do something more, some more iterations. The best one we got is 26.09. So alpha values are changing. The alpha values are changing. Since the alpha values are changing, the errors are also changing. So once we get a better value 26.09 or less than 26.09, we'll stop our iteration. 29, 33, 33, 56, 34, 46, 48, 31, 43, 36, 60, 41, 27, or 27 we got. 42, 29, 29 we got. 33, 37, 30, 32, 33. Oh, we lost it. 26. Oh, now we got 24.62%. So I'm going to stop my iterations over here. Okay. So I'm going to go and freeze these values. These are the values. I'm going to copy, paste special values. So now this is not going to change. Our iterations, we have stopped our iterations because we got a value less than 26%. So this is the best error we can actually achieve based upon the combinations we have here. So this model is called adaptive exponential smoothing model. And in this, what we're doing, we are taking three kind of alphas, and all these alphas are random. Okay. And we're building three models. Then we are building, calculating three errors. Then we are choosing the least error from here. Look at here, the least error is from the third model, the third alpha, 19.91%. In the second case, the least error is from the second model, 13.01%. In the third case, the least error is coming from the second model, that is 11.28%. So whichever alpha gives the least error, we will be getting that number over here. Is it third alpha or second alpha or the first alpha, right? This is what is going to give us. And then we are going to select that model, select that alpha model from where you're getting the least error. Then we're going to select that error from where we're getting the least error. So 19.91% is the least error, right? And then we will do the optimization by clicking on F9 to set the least error. So this is our adaptive single exponential smoothing forecast. And this is most useful model for the companies where people are not very conducive to data analytics. Okay, people are not very conducive for data analytics. People are not very educated with data analytics. So this kind of model is useful for those companies. They will get the best possible model, best possible output with minimal education of their employees on the data analytics or forecasting analytics. So if somebody wants to implement such kind of these kind of models, adaptive models, which are very intelligent, right? And at the same time, you don't want your team to have high training, then it is good. This is a good way to implement that. It's not very costly models. They're very. We can deliver these models at a very low rate, at a low time, and we can also educate your team on this. So it's a very powerful model, very adaptive model, very intelligent model, and it requires very less training of your employees. So this is how we can actually implement these models. It's very adaptive, very intelligent model. So guys, this is what we are actually we have. We came in for giving the program for this today's session. So if you have any questions, please ask your questions. I'll be happy to answer your queries. So you are now. It is your time now. Please ask your questions. Yes, we will be giving you the total in the training program. What we will do, we'll give you templates, right? This is a template which will give it to you. Second, we'll also give you the formulas, right? We'll give you the process. So all those three things will you get, and we'll also give you the video recording. Okay. So we'll also give you the video recording, so you can go and use templates, and every template will have formulas and process. Okay. And if you have any confusion, you can after the training you can go and access the video recording also, and then you can implement. These templates are directly implementable. So what I gave you the formulas and everything, right? The same formulas you can just take the same template and implement in your company with the same formulas. Right? This is not hard code. These are all not called hard code. These are all have formulas. If you look at there's a formula here, right? This formula you can take it. If you look at over here, the third one, there's formulas here. Formula here, formula here, formula here, formula here. Right? All these formulas are here. It's not hard coded. So these are templates. So just you have to put your data and get the output. So we'll give you this template. Suppose if you let me show you what we are having. Suppose this is one of the channels, right? We have these are some of the batches. Suppose if I go to one of the batch here, see this is all the templates. right? These are all the templates and PDF files and everything is there. So just you can go right click here, download this file in your local system, and you can download and you can store this file. And from this you can start implementing. And if you want to have good recordings, then all the recordings are available here, right? And if you want to go for some books, we have also books over here, right? So we'll provide all this free of cost. So books you get free of cost. You get all these Excel files, templates you can download. These are all models. Every Excel file is a model with the formulas, and these all models you can download and use it as a template for your projects. Okay, so this is what we provide. So this is a complete system is there. Once you register for the program, we will give you the access, right? So and we'll go into live training programs. So live training after the live training programs, you'll get the template, you'll get the books, and you will get the recording. So let's we assume today is a live training program. After this program, if somebody is registered, they will be able to access this. They will be able to access this template. They will be able to access the video recording. They will be able to access the content. And if somebody, our website is here. So you can go and visit our website, and you can go to the courses. Right, you can go to courses. And from here, you can go and book your courses from here. Right, you can book your courses and make the payments from here. Like you have a direct bank transfer, you have a credit card, you have Alipay, you have credit card, debit card, PayPal, right? You can choose any of them. The best is either Stripe or maybe the last option or maybe PayPal. You can choose any of them. So you can make a payment and you can register the course and we will take you to the program. Yeah, yeah. Yes, yes, you have that. You have that. Let me show you that one. So if you go to there. Yeah, that is the one. I'll show you where it is. So this you go to page number two. In page number two, you go, this is demand forecasting and inventory analytics. Okay, page number two, you have to go to page number four, and we have demand forecasting and inventory analytics. Can you see once again? Yeah, there is a time to start. As of now, if you go to insights or event section, go to event section, there are three programs right now we are launching. So there's a demand forecasting inventory analytics, 4th August, fast track supply chain, 2nd August. Okay, and supply chain risk analytics, 11th August. So these are the right now we are launching from 4th August. We are launching demand forecasting. Yes, guys, any questions? I think there's nobody's there, right? Okay, so let me know once you try to register for the program. I will assist you because this is the so I will assist you in making the payments and all. So just ping me whenever you want to register. Just ping me once, then I can assist you. Okay, so thank you very much, Matthew, for joining us today, and look forward for your participation. Okay, thank you very much.